Hello, been asked to do a video solution for 8.1 and 8.2. I added this to the primer later on when I was introducing stress and strain to the mini as a mini lecture, so that's why it wasn't there originally. So let's have a quick look and see if I can get the same as the answers. So what are the answers? So let's have a look. For 8.1 I should be getting 10 megapascals and 51 microstrain. Right, so 2 meter long bar, it's solid, tensile strength is 80 kilonewtons. The bar diameter, meaning that it's going to be a circular bar, is 0.1 meters. Young's modulus 200 gigapascals. Calculate the tensile stress. So when you're doing questions like this, usually just write down the equation, write down an equation that features the term that you're looking for. So we've got stress here. Stress is going to be a function of force over area, because I see that I've got forces here and it's mentioned in diameter, meaning I'm going to want area. Let's replace the area with the diameter now. So force over pi divided by 4, diameter to the power 2. Let's bring up our 4. So rearrange your formula before you put your numbers in. That's a bit ugly at the moment, so let's bring the 4 up to the top, and the d squared can go there. So the numbers that I'm looking to put in is 4. Try and convert your numbers with removing the SI units and the prefixes such as kilo, mega, giga, and so on. So here we got kilo. So let's put in 80,000. And pi. Here we're already in meters, so let's keep it in meters. We want to square that. So that's the calculations that we want to put into our calculator. So I will use my nice fraction tool there. So 4 times by 80,000. And then I can't seem to be going to the bottom. There we go. Okay, need to move like that. So I'm putting a pi in times by a 0.1, which I want to square. Okay, so that gives me this horrible number. Let's try and convert it to something sensible in engineering terms. Press the Eng button. Eng button is now converting this automatically into 10 times 10 to the power 6. So that's in mega. So 10 to the 6 is equivalent to mega. So we can have to 5 sig fig 10.186 megapascals. Okay, so that's part A. Part B, what is the strain experienced under these conditions? So we're looking at stress and strain here. So what we're going to do, stress and strain, what's the relationship there? Well, I know Young's modulus is stress over strain, and so I want to rearrange this to find the strain. So strain is going to be stress divided by Young's modulus. So I've got my stress. Let's go back and put it into times 10 10 point, I'd like to do a nice dot there, thank you. 10.186 times 10 to the 6. And then I want to divide that by 200 giga. So a giga is 10 to the 9. And then that's what I'm going to put into my calculator. So let's use the fraction thing again. So 10.186. Use that thing at the bottom to the 10 to the 10x when you're doing your powers. 6. Go down to the next line. Divide by 200 times 10 to the, again, you're going to use that little function at the bottom, times 10 to the 10 to the x, and put in a 9 there. And it gives me this horrible number again. Now let's see if the eng button will convert it into a nice engineering number. So I press the eng, and the eng button again converts it into sensible prefixes here. So here it's now got 10 to the minus 6. I know a micron is to the minus 10 to the minus 6. So that number is the number I want to use in terms of micron. It's 50.9, so I'm going to round that up to 51. So 50. I'll write out the answer first. 0.93 times 10 to the minus 6, which I should have really done here, I suppose. And then let's change this to micron. So to the nearest micron, 51 micron. So mu epsilon means micron, microstrain, sorry, not micron. Okay, so that's the solution for 8.1.